Hello, calculus fans. Continuing this new idea I have about reviewing for the final. So I did a somewhat more structured review. I talked through all the topics. Watch part 1 for that. If I were a student, the next step, if I think I have a general understanding of the topics, is I would make my note sheet. And hopefully you've already been doing that throughout the term. This is not a full note sheet. I was just sort of listing some of the things we talked about in the previous video. Theory, fundamental theorem of calculus part 1, how do we deal with total distance, just sort of the named things we did. Average value, arc length, center of mass, how to do volume with discs or washers, how to do volume with shells, and just whatever you need to add. Add more, you have lots of space. Here's my short version of the unit circle. Here's the half angle identity. There's other identities we need, but I was just saying there would be certain things you'd want. The next thing I would do is I would open a collection of old finals, if you haven't done this already, and keep a little list. So what we're going to do now, and let me make this a little smaller. So I have my little note sheet. I'm going to have things I might be adding to it. And then I might make a list. And this is, just a bit of organization to give yourself. Let's do this. So let's say this is, maybe I'll put it here, Fall 2014 final. And there's quite a few finals in the exam archive. So I just went further back because I know I've made a lot of videos from more recent ones. And I would make a little list for yourself. And when you're doing this sort of studying, you're trying to make sure you can kind of get a sense of what you're missing or what you need to study more. So we're just going to play the start game, meaning what is the first thing you would write? Most students that know the first step or two do pretty well on the exam. Of course, there are details, and those details are the things that separate, a passing grade from a much higher grade. But if your goal is just to, first and foremost, we need to pass and then hopefully do better. But the moment I see this, I go, odd power. It's a trig problem. That's one of the things we talked about in the previous video. You should have a plan of attack for what to do. And it's a situation where there's an odd power. So consult my previous video. That's what we did. But this has a very clear plan of what to do when it's odd. You might say the 5 is bothering you. If the 5 is bothering you, do a substitution. Now this is not necessary, but substitution is always a good idea in terms of cleaning things up. So dx is 1/5 dt, and this becomes 0 to pi over 2 because you put a pi over 10 here. And I'm just trying to write the first steps, but you don't want it to be like you have absolutely no idea here. 1/5. So I would just go a little further to confirm to yourself that you know the idea. And the very next step, if you know the idea in these problems, is to set up a substitution. That's what we always do. The only time we don't set up a substitution is when both powers are even and it's sine and cosine, and that's when we use the half angle identities. So if you don't know immediately to pull that out and then get this, then you're forgetting a topic. And you would just make sure, that's the moment you would stop and say, I absolutely need to review this topic. I need to make it so I'm not surprised the next time I see it. You have to change the rest to sine, so it's 1/5 pi over 2 sine squared, 1 minus sine squared. And then we're going to have u equals sine, and we're done. So let's make a few notes. This was a trig. And you might even make another note to yourself, an odd cosine. Enough that you can look back and be like, okay, I knew how to do that. Because I would like to get a little snapshot of how I feel about the exam. And so I would like to make a note enough on each problem that I can look at it again later and see. Okay, the next question, think about what jumps out to you. Make some notes. What jumps out to me is that these powers are the same. So I can see right away. First, I guess I can see that it's going to be a partial fraction. But I'm going to have to divide first. If you didn't see that, then that's something you need to put a star next to. And you could add it to your note sheet. You could say, okay, I need a thing that says, if it's a partial fraction, you can have your note sheet out. I need to check that it's reduced first, or else the techniques aren't going to work. So you come over here, you do division. We've done this several times recently in class. You subtract 2x minus 5. We're done, so this becomes the integral from 1 to 3 of 1, and then there's 2x minus 5 left over, and then this is in the denominator. Then it's a question of factoring. This part of the integral we can do right now. It's x from 1 to 3, but this one you're going to try to factor. Let's see, does it factor nicely? And the idea is you should try for a few minutes to factor. If you can't factor, then it must be irreducible. I need two numbers that multiply together to give 5 and add together to give negative 2. 5 and 1? No? Okay. I haven't thought of something yet, so now I'm going to complete the square. And you should have that plan of attack. So when you're going through and making your notes, and if you got stuck, don't dwell on it too long. You would like to, at least your first glance through some old exams, to just get a picture. If you're constantly having to stop and look things up, it's just going to take a long time. Now, the moment I complete that square, I see that indeed it is irreducible. And what I'm seeing is this, x minus 1 squared plus 4 dx. Then I do a substitution. But anyways, so there were some challenges there. But we should have known it's a partial fraction. The next one, that looks to me immediately like trig sub. And we should immediately know that x is 2 tangent of theta. So I'm pretty happy there. There are, of course, details, but I knew how to start. I know I'm able to get a long way into that problem. This looks weird, so it must be substitution. This is a substitution cleanup problem. And to me, the only reasonable choices for the substitution would be x to the 1/4, which probably works, or x to the 1/4 minus 2, which probably works. Note that if you do this, this means x to the 4th is x. And I suspect that's going to work pretty well because it's going to be t plus 1. It's going to be t minus 2. X is going to be t to the 4th. The derivative is going to be 4t to the 3rd dt is equal to dx. 4t to the 3rd dt. So it's the integral. It's going to be t plus 1. It's going to be a 4. And I've already spent too long. We need to move forward or this video is already going to be too long. Then it's partial fractions. So substitution and then partial fractions. So just work enough that maybe you can get a sense of the problem or a sense if you're completely lost. You will know things to do. So if you find yourself stumped, try a substitution, try the most obvious method. You will have time on the final to sort of try a few different things. Okay, then let's look at the other stuff. So what do we have for number 3? Determine whether the following improper integral converges. Okay, number 1, you're going to write it as a limit. So if you don't know that, you need that on your note sheet. 1 to t e to the negative square root of x over square root of x dx. Now we have to focus on the integration. I don't know how to integrate that. It looks weird, but it has a square root in it. So I would try this. You get u squared is x, 2u du is dx, and you just start integrating, and you worry about the limit piece at the end. The bounds become 1 to the square root of t, because you're plugging that in, e to the negative u over u, 2u du. Ooh, those cancel. I see my way to the end. So it's improper, and there was some substitution. But I feel okay about that, so let's keep going. What is this? This jumps out at me right away because I've studied a lot of old tests. Fundamental Theorem of Calculus, Part 1. And this is the sort of thing that this review helps with. So I think someone who does this sort of review is not at all surprised by a question like this. And someone who doesn't review several old exams is surprised by this. Okay, so this is position. It wants acceleration. So it wants us to take two derivatives. But the real interesting thing about this is that the first derivative is going to require the fundamental theorem of calculus. If you remember when we talked about this, I don't know why I can't write an S. S prime is the velocity. We talked about what to do and how to adjust. And in the end, this is what we got. We plug this in. You multiply times derivative of t, but it's just 1. You plug in the lower bound. You multiply by its derivative. So this is a question about the derivative of an integral. So they're not actually integrating at all. In the end, that's what you get, but the question wanted the acceleration, so you got to take the derivative again. So they mixed in a Calculus 1 review question, but if you want the derivative of this, it's the chain rule. E to the sine of t times cosine of t. And then here we have the product rule. Derivative of let's call this the second and first. So let's do first times derivative of the second, which is going to be 2 e to the sine of t squared, plus the derivative of the first times the second. Yeah, I know they slipped in a Calculus 1 question, but we're allowed to ask about Calculus 1 things in this Calculus 2 course. But no matter what, we should have had that first step. Times cosine of t squared times 2t. That's the derivative of this. And then times 2t, because that's the second thing. That's weird. Kind of a weird question. But the first observation was fundamental theorem of calculus part 1. Okay, we're going to keep going. Question 5. And this looks weird. So let's calmly read it. And the graph below the line. And this is the other thing you do is kind of gain some confidence in what the exams are and your approach to problems. By looking at lots of problems, you can go, okay, if I see something that surprises me, how can I think through it? And you can practice that. You have to pretend you're in a real test and have those experiences. In the graph below, the line is tangent to this curve at this point. Find the area of the enclosed region, this region. And you go, oh, this is an area question. I know that it's top minus bottom or right minus left. It looks to me like I'd want to do top minus bottom. And they're already telling me the equation for the bottom. So when I read this, I think I have a good idea of what's happening. 3x squared minus 6x plus 8. I know this has to be the bottom one because it's not the line. So basically this question has 3 implied questions, which is what is this, and what is this, and then ultimately compute the area. The line is tangent to the curve at the point on this axis. Oh, so I do know one of the values. The beginning of the area is at 0. So I guess there's only 2 things you need to know, which is where does the region end? That would be nice to know. And what is the equation for the line? So they mixed in a Calculus 1 question. We need the equation for the tangent line. Lines look like this. When x is 0. Well, x is 0. Well, what's the y value? Well, the y value is going to be whatever happens when you plug in 0 here. So that's 8. What's the slope? Well, what's the slope of the tangent line at 0? It's the derivative. So it appears the exam this quarter, they were slipping in more review. But that's good. We don't want to be surprised by that. We plug in 0, we get negative 6. There's my line. It's negative 6x plus 8. Done. Not quite done. You need to know where that intersection point is. Is that going to be easy to find? Let's see. So lastly, I need the intersection of these 2 curves. So it's going to be negative 6x. That worries me. I'm kind of pausing here because I'm like, that's going to be a cubic. My guess is it simplifies a lot, or I'm hoping it does. Yes, the 8's cancel. I see it now. Not only do the 8's cancel, the 6x cancels. So you subtract 8 from both sides, the 8 cancels. You add 6x to both sides, that cancels. So you're just left with x cubed minus 3x squared. And that completely factors into x squared times x minus 3. And so they intersect at 0, which we already knew, and 3. Okay, so ultimately what was this? This was an area question. It was a top minus bottom. It did require we think at it a little bit. And it did require we remembered what a tangent line was. So there's a bit of review. But there's some pieces we should have known to fill in. Okay, then what do we have here? Volume. You say, well, it looks weird. I'm confused. It's a volume question. We're rotating around this. This was a popular question. I think later we removed it from the homework and we haven't asked this as much. But it's a question that used to be in the homework. Ultimately, what they say is they're drilling a hole through the middle of a sphere. And so this question starts with a circle. So any volume question we're asking in this class must be starting from something in 2D. We didn't do general volume. We did volumes of revolution, or volumes where we knew the shape from one thing. And what they said is they're cutting it here and then rotating it around to make this bead or whatever. So you can use X or you can use Y. It doesn't tell you the way to do it. It does tell you what the big radius is. And what so the radius of the circle. So the circle is x squared plus y squared is big R squared. And this is little r. So this is your first starting place. And since we're doing the whole volume, I would just do the top half and multiply times 2, meaning I would find all of this volume. But now's when we got to make a choice. We're either going to do, so if you do it in terms of x, then your very first step, and watch my previous video where I reviewed this, you're going to label this x. And let's say we're just dealing with this. The moment you decide to label it in terms of x, then you should know the method we're using. The method we're using there would be shells. You could immediately write dx 2 pi blank blank. That's this in our note sheet. We have that piece. This is going to be x, and this is going to be the height. And when I want the height, I'm going to have to solve for y. So if you know that the game we've played a lot, you have a lot of ideas here. And then we're going from R to big R times 2 because that's only going to be the top. So this was a volume of revolution. So would you have had some ideas there? Where would you have gotten stuck? Let's keep going. Okay, this looks like a work question. Actually, I think I copied this and put it on an old midterm. So you should know right away that the question is about, so you might have seen this in studying for one of the midterms. I'm giving away my secrets here, but you label this y. It's being pumped to the top, so you're going to say the integral from 0 to 1 of 16 minus y. And the weight is 15 pounds times length times width times dy. And that's it. And then your job becomes labeling how far this is. They told me the length was 3. So I already know this is 3. So let's put that there. This is 3. So it all boils down to labeling that length. And it's a labeling question is what this is. It's not really a work question. It's a question of, if I tell you that this point on this edge is x, y, and that it satisfies y equals x to the 4th, and then I give you a y and I ask you for the x, you're going to have to say x is y to the 1/4, and then that's going to only represent this far, and that's not what I want. I want the width all the way across, which is going to be twice that. So you're going to go from 0 to 1, 16 minus y, 15, times 3, times 2, y to the 1/4 dy. So work pumping with rectangular cross sections. Okay, let's keep going. Arc length question, this is very quick. 1 to 3 square root 1 plus 2x squared dx. And then we're approximating with Simpson's rule. Well, because I'm approximating, I think it probably would make our lives easier to simplify this first. Delta x is 3 minus. So I'm not going to actually do this because I feel like it's just using the formula. So arc length and approximation. That's pretty fast. I feel good about that. So you can kind of make as you go notes of what's challenging to you. Then we have a separate and integrate. So step 1, separate. That's actually secant squared. So it's secant squared of y dy equals t sine of t dt. That's an integral. I know that's an integral. I go, I think I'm pretty good. This is going to be integration by parts. Pretty happy with that. And then we have an advertising company introduce a new product to Seattle. Let P of T be the number of people or in thousands. So some sort of population problem who are aware of the new product. Seattle has a total population of 700,000. Initially, no one has heard of the product. Set up a differential equation for P. If it increases at a rate proportional to the number of people in Seattle unaware of the product, also state the initial condition. I think this is a little more advanced than what we currently ask, but let's try to translate this directly. I have something like this on my practice sheet. The rate of change is proportional to the number of people that are unaware of the product. That's going to be 700,000 minus P. So that's just translating it directly. The initial condition is that P of 0 is 0. Then we're going to separate and solve and plug in information. So it's a population problem. Separate and solve. So then you kind of stop for a moment and you say, where was I stuck? Do I have those things on my note sheet? If there was a hard question, would I have been able to make some progress? And then you can play the game again. This is a good way at some point in your studying to play this game. So now let's speed up a little bit because I'm sure this video is already way too long. If something like this is helpful to you, can let me know. I'm spending a lot of energy on videos this term, and I'm not quite sure what's resonating with students. My goal is for students to do well, but I don't often hear back unless a student is unhappy. So anyways, let's look at fall 2015. This time we'll do just sort of a confirmation of quick things. So the first one looks to me like I will need to simplify or do substitution. Simplify, substitution. So that's a challenge I can come back to. B looks completely like a substitution. Kind of a weird collection of problems. Oh, I think the second one is substitution. And then probably will become a partial fraction. Okay. Then we have a trig sub. And as you're doing this, you can ask yourself the first step. The first step here would be x equals secant of theta. Then we have an arctangent, so that's going to be a by parts. And you should realize that you're going to pick this as your v, and that you'll need the derivative. As your u, sorry. And then your dv will be everything else. Take the derivative, integrate, go. Doing this a few times can get you some confidence. Okay, the region, determine whether the area of the region is finite. Okay, so this is about a region. We have some sort of function. I equals 1. Probably going to be some sort of asymptote. I also know what that looks like because in my head I thought of it like this. So it's saying the integral from 1 to infinity of this thing. Okay, so you might have to do a bit of thinking to get there, but then you know the next step is to write it as a limit and then evaluate an integral. So most of these questions end up being integrating, but make sure you do that first step. So we have an improper. Oh, and there's a volume in part B. So you can ask yourself, if you rotate around the y-axis, what would the volume look like well, I might call that x and do shells, because it's going to be 1 to infinity of 2 pi x times the height, x to the negative 3 halves. Simplify, integrate, see what happens. Okay, what's next? A leaky bucket. So we have a work question. Leaky bucket. We could talk more, but we have a center of mass. So above the x-axis, give your answer in exact form. Oh, this does x for x bar. It's below this function, so it's going to be the integral from 0 to pi over 2 of x times sine squared of x dx divided by the integral from 0 to pi over 2 of sine squared of x dx. And then y bar, oh, I think maybe we have some symmetry. Right. If this was on the final, I would probably advocate to include a picture. Oh, maybe there's not symmetry, because pi over 2 gives me a 1 and 0 gives me a 0. Oh yeah, no symmetry. This is just a long calculation. This integral we know, and will be pretty quick with the half-angle identity. This integral looks like integration by parts. And then we have a half. This one's not very nice either. And then this. So it's a computation problem. I suspect it's a pretty long computation. But one of those where you can get a lot of points, hopefully you get them all. Area under a curve, divide the region in half. So that's going to be about labeling and just knowing how to work through such a problem. I think it's pretty short. Then we have a region, square root of x equals 4, and it's rotated around the line x equals 6. And you don't panic that it's not one of the axes. It doesn't really change our approach. Volume using cylindrical shells. So step 1 is you would label x. That leads to a cylindrical shell. And then you have the integral, x equals 4, in the x-axis. Okay, so you're going to go 0 to 4, 2 pi blank blank. This should be the radius of your shell, which is how far from the middle to the edge, and that's going to be 4 minus x. Not 4 minus x. It's going to be 6 minus x, because this line was 6. I was misreading my labeling. So from here to here is going to be 6 minus x, and the height is going to be the square root of x. Done. Set up an integral for the volume of this using washers. If you did washers, it's going to be in terms of y, dy, pi squared. The smallest y can be a 0, the biggest y can be its 2, so 0 to 2. And then you're going to have to figure out a couple things. Here's 6. You have to figure out how far it is from here to here, that's the inner radius, and how far it is to the edge, that's the outer radius. So the inner radius is 6 minus 4, because this is 6 and this is 4, and then 6 minus however far it is from here to here, which you should know because the equation is y equals square root of x, so that means x is y squared. Okay, so we had another volume labeling question, and then we had arc length. That's a fairly quick, somewhat straightforward type of question. And then we have a separate question. So if you're stuck here, you should immediately be thinking, there must be a way to factor or they can't ask this. So you look for anything that can be grouped or factored. And to me, the only thing that jumps out at me is the y squared. And the moment I see that, I'm like, oh yeah, I can factor this. So yes, it was a little bit harder factoring, but what else are you going to do on this question? Then we can separate and go. Okay, so that's something I kind of know. And then we have a Newton's law of cooling. At this point, you should start seeing some trends. Not that our exam will be exactly like these, but you can start to get a feel for what is there. There's a lot of similarities between those two exams, and a lot of similarities between those exams and our final. Let's keep going. I'm just going to glance through this one and not take notes. We have a trig. We should immediately be setting up a substitution. We have an inverse trig, so we're going to do integration by parts. We have a trig sub, but we're going to have to complete the square. We have a partial fractions, we're going to factor the denominator. So you should have a lot of ideas about what to do in each of those problems. Don't leave anything blank. Get as many points as you can. Then we have a volume question, so we'll draw it, we'll set it up. We have a T and a 2T. So you can ask yourself, what in the world is this question about? So I'm just writing down what it says up above. You can read, but it says, write down a formula for this area and then take the derivative. It's a fundamental theorem of calculus, part 1. So it means it's a short question. Times 1 and times 2. There we go. We have find the area between those two things. Find the intersections. We have a volume question, and it says the cross sections are not washers but triangles. That sounds worse than it is. If it's a triangle, the area of a triangle is 1/2 length times height. And they're telling you in terms of x, we can figure out these pieces, and that x has radius 2. So the challenge becomes how we label these sides. And I could talk about that in a separate video if somebody wants, but it's labeling. Calculus student lifts a sandbag. This sounds like a leaky bucket problem. Separate and integrate. So first step is we're trying to factor. And any of these I can talk about more if you ask about them. But right now we're just focusing on the idea. And then we have a mixing problem. So I would say we just looked through 3 exams. And at the end of that, you should have an idea of where maybe you need to study a little more. And then you can worry about dealing with some of the details and adding to your note sheet. But I hope you saw on all of those exams that there's no page that should be blank. You should have something to write on every page. And in writing about the problems, you should find some more pathways. You should also go back and check your work wherever you can, plug in numbers, check your arithmetic, have a plan. Don't panic, but don't leave anything blank. All right, I hope that's sort of helpful. Let me know if it is.